Section 5.4, looking at equilateral and isosceles triangles. So an isosceles triangle, which we talked about in section 1, is a triangle with two congruent sides. So defining some terms, if we look at this, we're going to say these two sides are congruent. We're going to label this ABC to match what goes on in the next problem. So the sides that are marked the same, AB and AC, those are legs. Okay? The side that is not a leg is the base. So in this picture, BC is the base. The base is not necessarily the bottom. Okay, if we turn this upside down, all right, and that's how I gave it to you. So A is at the bottom, BC is still the base. Okay, so base does not mean bottom when we're talking about a triangle. Sometimes it's what the height hits. In an isosceles triangle, it's the side that is not a leg. Okay. So then, one of the other things we'll see talked about are base angles. Base angles are the angles that the base touches. So angle B and angle C are base angles. Okay. There's a couple other points you can get into, but those are mainly the ones that we will be using to start off. So first thing, base angles theorem. If two sides of a triangle are congruent, then the angles opposite them are congruent. So if AB is congruent to AC, then angle B and angle C are congruent. So if you have your isosceles triangle, your base angles are always congruent. So example 1 asks us to find x and y. They tell us that angle y is 50. Right? They give me these two sides are congruent. So x and z then have to be congruent. Those are my base angles. So 1, I know that angle x is congruent to angle z. I also know my triangle adds up to 180. So if I do 180 minus 50, I have 130 between those two angles. Divide that by 2, then each one of those is 65. So angle x and angle z are both 65. Example 2, right, I have 90 here. So there's actually a couple things we could do on this problem. Okay, 3x and y plus z, or y plus 7, those have to be equal. If I just had x's here, the easiest thing would be set them equal and solve. Since this is 90, and these two have to add up to 90, based on our corollary we went over in 5.2, I could add them to 90 as well. That's not helpful again because of the x and y. So because this is 90, if I do 180 minus 90, these are both have to be 45. Divided 90 by 2. So 3x equals 45, and x is 15. Y plus 7 equals 45, and y is 38. Then we have the converse of the base angles theorem. That says if two angles of a triangle are congruent, then the sides opposite them are congruent. So if angle B is congruent to angle C, then AB is congruent to AC. Okay. And when you're trying to look at opposite parts here, one of the things that can help is to draw a line. Opposite B is AC. Opposite C is AB. Right? Same up here. Opposite AC is B. Opposite AB is C. Okay? It also in a triangle, if we say opposite, it will always be the side the thing that it doesn't touch. So like AC touches angle A, touches angle C, angle B is the opposite. So then flipping our paper over, it says find the value of X, then find the perimeter of the triangle. Okay. When you're given these problems, watch what's equal. All right. Here, X plus 6 equals 3X plus 2. My battery's going. All right. So I have 2X plus 2 equals 6. And 2X equals 4. X equals 2. Then I'm going to plug in and solve. And I'm running short on battery, so I'm going to switch over to paper I have that has stuff written out just to save some time here. All right. How do I not have perimeter on here? All right. It also asks me to find perimeter, so I'm going to plug in. This is 8. This is 8. So 8 plus 8 plus 12 gets me to 28 inches as my perimeter. All right. So then corollary to the base angles theorem says if a triangle is equilateral, then it is equiangular. Corollary to the converse of the base angles theorem, a triangle is equiangular, then it is equilateral. So if I know a triangle is equiangular, it's also equilateral. If it's equilateral, it's also equiangular. We mentioned that in 5.1, but here we formalize it. Okay. And then we have solving our problems here. All right. So find the value of X and Y. Watch what's congruent. Here they give me all these sides the angles are all congruent, so I know these sides are congruent. And the markings would have to be here, all right, to know that these two sides are congruent. That lets me know that 9y minus 10, 5y minus 8, and 2x plus 13 are all equal. Okay, the only side that's different is this side over here. So I set these equal. I set these equal. I solve this one first because I can solve for y. 5y minus 8 equals 9y minus 10. Solve, get y is a half. So plug in a half for y over here. Solve for x. And I get x is negative 9.25, which is kind of weird, but that's our answer. Example 3. We're looking again at what they give us is congruent. So we have sides that are congruent. So all our angles are congruent. So 180 divided by 3 means they all have to be 60. So 3x equals 60. Here, these two are equal. So these two have to be equal. So 72 equals 9x. Here, these two sides are equal. My angle's 90. So both of these have to be 45. And I solve that. For D, and they give me these are equal and these are equal. That means these three sides are equal and these two sides are equal. All right, so y has to equal 4, but x plus 1 has to equal this, which also has to equal 4. So that's what I'm solving there. Okay. Then on example 4, they asked me to solve x, y, and z. So I'm using what they mark as well as my triangles add up to 180. One of the things here is think of what triangle you're looking at. So like in this triangle here, right, they give me these two sides are equal. So these two angles are equal. So I do 180 minus 64, divide that by 2 to get my x. Right? Here I know this is 64. Subtract from 180, I get this angle. These two have to be equal. Okay. So that gives me 180 minus 64 to the 116. Oh, right, yeah. So, okay, that's that 116. I actually solved z first over here, right? These two have to add up, and this is 90, so I can do that once I know that's 58 from here. You would also solve these two together, 180 minus 116, divide that by 2, because these have to be equal, I think, right? Oh, no, they don't mark it that way, so I can't use isosceles up here. That's why I have this statement here. And then on the far one here, I have this triangle, right, that has X and Y in it. We have this triangle here. So these two sides are equal. So I know X, or I'm sorry, I know Z and this angle are equal. Right? Based on this triangle, X and this angle are equal. So X has to be 68 based on this triangle. Right? What do we do here? So then this triangle here, then this weird one here, I have X, 76, and Z. That lets me solve for Z. And then in this triangle, I have Z, Z, X. Add those, and Y. So X and Y are one angle when we look at this here. So that's why we have four things there. Okay. This one's probably about as complicated as these problems get. Right. As we're looking at that. So watch what triangle you're looking at here. We have this one. We have this one. We have the large. We also have that skinny one, but that skinny one's not really helpful. Okay. So that is looking at our isosceles triangles and the end of section 5.4. Took the end a little fast there because again the battery's running out. But hopefully we can see all the work and it makes sense.